Hello everyone and welcome back to the MAE 52 virtual discussion series. This is session 5. I am Colin. In this session, we're going to focus on the midterm project and how to create an engineering drawing. We're first going to start by building up the part that's the midterm project, and then we're going to learn how to take this part and put this in the drawing environment and add appropriate dimensions and callouts and format an engineering drawing. So let's first take a look at the part. This is one part that I think really benefits from a slow buildup of more simple features into a more complicated looking part. So the way I like to start with this is build the base, then this cylindrical extrusion, followed by the remaining rectangular extrusions that create this part of the feature. There's also a couple other features we need to be careful about. Specifically this main bore into the part with this conical tip, and then these threaded features on both of these faces, because these features will require a special tool called the Hole Wizard, which we will address, and there is a PowerPoint supplement to help specifically with these features on the midterm project. All right, with that, let's begin. All right, because we are starting with the base of the part, let's look at the dimensions for the base in this zone of the drawing right here. We see that the base is 4 inches by 4 inches, and each one of the corners has a fillet on it of radius 0.75. So let's begin there. We're going to open up a new part in SolidWorks. We're going to make sure the part is in inches, great. And to keep the part in the same orientation that we see on the drawing, which is going to be very important, we're going to start by inserting the sketch for the base on the front plane and extruding out from there. So we'll insert a sketch on the front plane. We'll grab the center point rectangle, snap the center to the origin, and we'll dimension this at 4 inches by 4 inches. Great. All right, now I'm not going to add the fillets at this point. Because I want the option to potentially dimension to that corner, I'm going to add the fillets after I create the base. So right now the drawing is complete. I'm going to extrude this base, and looking at the dimensions, we see that the base is 0.5 inches thick. Right. So we'll extrude out 0.5 inches. I'm going to leave this as a blind extrusion and keep the front plane on the back of this face. Okay, excellent. And we'll go ahead and name this base. The next thing I'm going to do is provide the hole pattern. So I can see that the holes are 0.75 in from each edge and 3.25 inches in from each edge. So what I'm going to do is actually build up a square, and each corner of the square is going to be a construction circle, will be a snap point for the center of each circle. So I'm going to insert a sketch on the front face of this base that I've created, look normal too. What I'm going to do is grab the corner rectangle, draw a rectangle, and now I'm going to dimension each one of the edges. So this is 0.75, this is 3.25, and then same thing from this edge. This one is 0.75, and this is 3.25. Okay, so now each one of these corners will be the snap point for the center of the circle. But what I'm going to do first is select this rectangle and make it for construction so that it won't interfere with the circles themselves. This will just be the snap points. Now what I'm going to do is, because I noticed that these circles, there's 2 different diameters. That's because this feature has a counter bore in it. So I'm actually going to provide both circles at this time and then extrude them at different times. So we're going to put in 8 circles and we'll dimension them in just a moment. So 1, 2, 3, 4, 5, 6, 7, 8. Now because of the callout, all of the circles have the same diameters. So what I'm going to do is select all the large diameters by holding Control at the same time and make them equal. I'm going to do the same thing with all of the smaller diameters. And this means that I will only have to dimension 1 set. Okay, great. Now what I'm going to do is look at the drawing, and this is the callout for the holes. So if you're not familiar with looking at a callout, this is what it says. It says there's 4 hole instances. The smaller hole is 0.397 inches, and it goes through the entire part. Then there's another hole that is only partial depth, at 0.875 inches. And this symbol right here signifies that it's a counter bore. So what we're going to do is we're going to first dimension the smaller hole, 0.397. We'll dimension the larger hole at 0.875. Okay, so now I'm going to exit this feature or this sketch, and then we're going to create the feature one at a time. So you're going to see when we get into the extrude cut, it's going to try to cut an annulus. So what I want to do is actually go to selected contours, clear the selection, and I want to select these one at a time. So the first thing I'm going to do is select the small set of holes, and this is going to be through all. So the condition is going to be through all. All right, so now we've cut the smaller hole. What I'm going to do next, and actually we can name this, we'll call this small hole. What I'm going to do next is reuse the sketch, extrude cut, and then once again, I'm going to select the appropriate contour, which is already selected, but we'll do it again. And this one has a depth of 0.1 inches. Okay, excellent. And we'll name this one the counter bore, C bore. Okay, great. So that feature is complete. Now, what I'm going to do is add the fillets onto the base. So the fillet was radius 0.75. So we'll select all of these edges. We'll set this to 0.75. And this could be done at a later step as well. Like I mentioned, I like to keep the edges available in case I need to dimension to them. But at this point, I don't think we're going to need those, so it's an okay time to put on the fillet. So the next feature I like to add on the part is this cylindrical extrusion. So looking at this, we see that it's only called out here as a radius because this edge is only a partial arc of the circle. So we're going to have to double this to create the diameter of the circle. It's located in the center of the base, which we can snap to the origin in this case, the way we've dimensioned the base. And then we see from this view that from the face of the base, this face right here is extruded out 4 inches. So what we're going to do is add the sketch onto this face. We're going to snap a circle to the origin because that's in the center of the part. And it was radius 0.875, so we can do this, 0.875 times 2, get the diameter, exit the sketch, and we'll extrude this 4 inches out from the face of the base. Perfect. We'll call this cylinder. Okay, excellent. So now what we're going to do is actually, from this face of the cylinder, build backwards. And if you look at the part, you can see that there's 2 somewhat rectangular extrusions. And I know it's a little hard to see that they're rectangles now, but it'll make sense in just a minute. And each one has a different depth of extrusion. So let's work on the larger one first. It's really important to notice, both from this view and this view, that this meets up tangent to the edge of the circle in both cases. That's going to be how we dimension it. So now that we've met up tangent to the circle, we have the width, but we need to figure out the height. So we can see it here. It's dimensioned from the center of the circle 1 inch. So we're going to remember that. We're going to insert a sketch on the face of the cylinder. We're going to create a rectangle. We'll just make it arbitrary right now. Then what we're going to do is make sure the sides of the circle and the sides of the square are tangent to each other. Next, I'm going to make sure that this line meets up with the origin because it's the center of the circle. So I've just dragged it around. It found a snap point on the circle. I can also select that line and snap it to the origin. And then the next thing I need to do is dimension the height, which we saw was 1 inch. Great. All right, so now we're going to double check the drawing, make sure that we have the appropriate dimensions, we didn't miss anything. And next we need the depth of extrusion. So we can see it right here, and it's 3 inches. So we're going to exit the sketch, extrude. Now we need to change the direction. We'll select 3 inches. Perfect. Now I've chosen not to cut any holes into the cylinder just yet because I want this material to be absorbed. It will help make these features much easier. After that point, then we'll simply cut the circles in and we won't have to provide any extra relief cuts from the material intersecting. Perfect. All right, and we'll call this upper rectangle. The next thing we're going to add is the side rectangle. So we see this right here. Okay. Now this one's a little bit tricky. So the dimensions for the width here, we see that it does meet up tangent with the bottom of the circle, but for this width or height, however you want to think about it, it's 1.25 inches. And then the depth of extrusion is still shown in this drawing, and it's 2.25 inches. So we're going to insert another sketch on the front of that cylinder, insert a rectangle. We'll do the same procedure. So we'll make sure that the bottom side of the rectangle is tangent to the bottom of the circle. We're going to meet up with the center of the circle, so we'll snap this to the origin, coincident. And then we saw that it is from the center of the circle, it is 1.25 inches tall. And then from the center of the circle, we can see that it is actually dimensioned here, not from the center, but from the side of the circle. So you have to be careful. A lot of times you'll want to look for it being dimensioned from the center, like the other rectangle, but this one, it's dimensioned at 3.25 inches from the side of the base. So even though the base is at a different altitude, we can still provide that dimension. All right, so 3.25. And then that is a fully defined sketch. So we'll exit the sketch and we'll extrude this backwards 2.25 inches. Perfect. So now you can see that that just slow progression of very simple shapes has created this more complicated feature. And it really just took 3 features because these are really 3 separate features and they're extruded at different depths. So those are some giveaways that we should do this in 3 different parts. And we'll call this one side rectangle. Okay, perfect. So now let's take a look at the drawing. So there's a couple places we could go. I think the easiest one right now is creating this little square pocket in the side rectangle. So let's take a look at this. We see that it is a width of 0.313 inches. And actually, when you're looking at a drawing in inches specifically, because this has been rounded to 3 decimal places, then we see 0.313, which may look a little bit strange, but actually this is 0.3125, which is a common fraction of an inch. So if you want to put in those 4 decimal places, we're only going to show 3 on the drawing, and 3 is still correct here. But oftentimes in drawings that are in inches, you will find this. For example, this radius here at the base, it says 0.188. It's really 0.1875, which is 3/16 of an inch. So it's just something to remember, because a lot of times, if you're looking at a drawing, if you're unsure that it's in millimeters or inches, or you see a dimension and it looks a little bit strange, it could be some giveaways that either it's a fraction of an inch that is missing a decimal place, or is in fact in millimeters. Of course, this whole dimension, or this whole drawing, is in inches, but just to let you know why that number may seem strange when some of the other ones are nice fractions of an inch. Okay, so we see that the width of that pocket is 0.313 inches, or 0.3125. The height is 0.625, and this is a really tricky dimension right here. So we see that it's 0.1 inches, and that's from the center of the circle to the top of that rectangular pocket. So let's go ahead and apply that sketch right now. So we're going to insert a sketch on the front of that cylinder again. Put in a rectangle. Okay, so now let's make sure that we drag the top of this rectangle certainly above the origin so that we can dimension it easily. So from the origin, which is the center of the circle, this is 0.1 inches. The width is 0.3125. And then the height is 0.625. And as a reminder, when we're in the sketch area, if, for example, we're only looking at 2 decimal places and we want to see more, we can select on any dimension, and over at the side, under the dimension properties, we can change under the tolerance and precision this number to have as many decimal places as we would like. So, and we'll look at it like that. Okay, great. Now the next thing we have to do is just make sure we place this rectangle in the proper position laterally. So we'll look back at the drawing, and we see that it is 1 inch from the center of the circle. Oops, let's redo that. We accidentally grabbed the corner there. So 1 inch. Okay, great. So now we've located that rectangular pocket. Let's go back and look at the drawing. The depth of the cut is shown here with the section view because no other views are going to show the depth of this pocket without hidden lines. And of course, we can't dimension to hidden lines. So we're required to have a section view that shows us the complete depth of the pocket, and then we can dimension to the solid line. So the depth of the pocket is 2 inches. Back here, extrude cut, and we'll extrude that back 2 inches. Perfect. Okay, so now we've completed the rectangular pocket cut, and now it's time to provide the features that use Hole Wizard. So what I'm going to do right now is show you how to do that, and we're going to have kind of a special section for that tool. Okay, before we get into the Hole Wizard tool, we're going to need to provide the hole locations ahead of time. So when we get into the Hole Wizard tool, there's a utility for locating the hole positions, but it likes snap points. So if we provide the snap points ahead of time, it's going to make life a lot easier. The next question is, why do we need the Hole Wizard tool? Well, let's take a look at some of these features in particular. So we see the center bore has this conical tip, and then these other sets of holes have this kind of unique callout. Well, these ones are threaded holes, and then this center bore with the conical tip is representing something that was created with like a drill bit. Okay, now if we were just use extrude cut, for example, we would have a flat bottom hole. But we know that if we use a drill bit, when this goes in, we're going to have that conical tip. The drill bit has that tip on there so it can penetrate the material, and then it can remove the chips that come off. Now, if we want to represent how this hole goes into the feature, we'll need to keep that conical tip, because if we were not careful, for example, and this hole went too deep, that might actually go through the base of the part. And so that would represent in real life, if we were to drill the same hole, that might go through the base of the part. So there's a lot of reasons why it might be nice to represent that real conical tip on the part. And then of course these threaded callouts. So when we make a threaded hole, in the case if this was made of aluminum or something like that, we would drill a smaller hole first, and then we would use a tap to cut the hole to the final diameter size and cut the threads at the same time. So we see here for a 3/8/16 hole, so that means that it's 3/8 inch major diameter, or 0.375, and it has 16 threads per inch. But this call out up here is telling us that the first hole we drill is at 0.313. And of course that hole has to be smaller because the tap's going to cut the hole larger to the final size. Now, how do we know that information? Well, we could look in something like a machinery's handbook, and it would tell us for this 3/8 inch hole that we need to drill this smaller hole at 0.313, or the Hole Wizard has this information embedded in it. So if we're doing something like holes, especially for like a subtractive manufacturing type part, then the Hole Wizard has this information built in, and it's a really easy way to make this feature. All right, so let's get into the part, and we'll make the hole locations first. So what I'm going to do is select the top face, insert a sketch, and we can see that the holes are located along a center line, and that center line is for this hole that's cut, but that's also in the center of the cylinder. So we're just going to put a center line, snap the circles to that line, and then we'll dimension it 0.875 and 2.125. So we'll grab a center line, and we'll put 2 circles. We're going to hold Control, select both circles, make them equal because they're the same circle, and that way we only have to dimension one of them. Now, we don't have to put any specific dimension because the Hole Wizard tool is going to decide that for us, but I usually like to dimension it to the size of the called out pilot hole, and that way, after the Hole Wizard procedure is done, I can cross-reference it and make sure that I have the correct size hole. Also, if we want to show more decimal places in our sketch, we can just select any dimension, and over here in the dimension properties under tolerance and precision, we can select to show more decimal places. So we see the 0.313. Okay, so now this hole is 0.875 from the front face, and this one is 2.125 from the front face. Once again, we may want to show more decimal places. Okay, perfect. Now, the hole wizard is just looking for snap points. So actually, I'm just using the center of the circle. For that reason, I could have used anything else that has a point on it. I could use the point tool. I could use 2 center lines, but I think the circle is a really intuitive, easy way to do this. So we'll exit that sketch. I'm going to name this just so I don't feel like I have a floating sketch. I'm going to call this upper threaded hole locations. All right, and we'll do the same thing for the sides. So we'll insert another sketch. I'm going to put in a center line, snap it to the front face. Now, looking at the drawing, those holes are located above the bottom at 0.625. So let's go ahead and dimension the center line right now. It's at 0.625. We'll put 2 hole locations, circles, on the center line. We're going to hold control, make sure they're both equal. And looking at the drawing, they're both at 0.257 inch diameter. 0.688 is the first one from the front face, and 1.558 is the other one. So first dimension the holes at 0.257. This one is located at 0.688, and this one is located 1.558. All right, perfect. So now we have the hole locations. We'll name this side, we'll call it side threaded hole locations. Okay, perfect. So now we need to provide the location for the center bore. So we're going to insert a sketch on the front face. This one we can just snap to the origin. And this one is 0.75 inch diameter. Perfect. And we'll call this center bore. Center bore. Okay, perfect. So now we have all of the hole locations. So it's time to open up the hole wizard. Now where we find the hole wizard is right here next to extrude cut, but we have to be careful. Under hole wizard, there's another tool called thread. And so 4 of these holes are threaded holes, and there might be the tendency to use the thread tool, but here's the difference. The thread tool cuts real 3D threads into the part. So if we were making this part with a subtractive manufacturing process, like we had built this up out of aluminum and it was time to make these holes, we would first drill the smaller hole, and then we would use the tapping tool that I mentioned to cut the hole to the final diameter and cut the threads in it. If we were to, however, make this with an additive manufacturing process, like 3D printing, we would not cut the threads into the part after the hole was made. We would want the threads to build up with the part. So if we were making this with an additive manufacturing process, we would use the threaded tool. But if we're making this with a traditional drill and tap procedure, then we need to use the hole wizard. If we use the thread tool, it will be the incorrect hole. So I've seen this mistake made on the midterm project. It will look different on the drawings, and it will be a different part. So make sure you select hole wizard for this part. All right, so we select hole wizard, and let's make the front bore first. So there's a lot of different hole types, and we hover over the different hole types, and if you leave your mouse on it, it'll tell you the name of it. So the one we need to select is called hole, and the little diagram kind of shows us what we want, but the hole is just going to represent a drilled hole. So we select that. Now we go up here to the top and select the positions tab, and then we click 3D sketch. When you click that, you can see if you hover your mouse over one of the faces, it starts to put in a hole normal to that face. So you can see now why it's really helpful to have the snap locations ahead of time. So what we're going to do is go snap to the center of that circle, and then we're going to go back to type, and we're going to now select the size. So it's really small right now, it's kind of hard to see, but we're going to make sure this is the correct size. So we're in ANSI inch, and then we're going to double check the drawing. So the hole is 0.75 inch diameter, and it goes to a depth of 3.75 inches. So go back here, down to the hole size, we have to scroll down. We have to find 3/4 of an inch. Getting closer, getting closer. 5/8. There we go, 3/4 of an inch. And now we need to select the depth. So we want to select blind and then 3.75 inch depth. And so this is not going to be to the bottom of the point. This is going to be the depth of the constant diameter. So we select 3.75. We press OK. And now that's drilled the hole. And maybe we want to section this part just to make sure that we have the correct hole. So we're going to select the section tool, take a look inside, and we see certainly that we have the correct hole with the conical tip. And if we want to just make sure that we have the correct dimension, we can use the evaluate tool. We can measure from the front face to some location. We'll select the correct units here. And we see that 3.75 inches for the constant diameter. Perfect. Okay, great. So now we need to do the same thing with the other set of holes. And I'm going to hide this sketch now because we've confirmed that it's the right diameter. We don't need to see it anymore. All right, perfect. So let's go back into the hole wizard tool. This time, instead of selecting hole, we're going to select the next button. It's called straight tap. And straight tap means that it is a threaded hole. So we select straight tap. And then let's do the top hole first. So we're going to select the positions. We're going to snap to the center of that circle and snap to the center of that circle. Make sure we get it. Perfect. Go back to type. Okay, so looking at the drawing, these are 3/8-16 UNC. So UNC means it's a coarse threading, but 3/8-16, 16 threads per inch for a 3/8 inch major diameter hole already means that it's coarse threading. And we're going to see that when we go back into the hole wizard tool, ANSI inch again. When we select the size, now it looks a little different because there's a dash number. So one number is the major diameter, the other ones are thread per inch. And you see for a 3/8 inch hole, there's only 3/8-16 and 3/8-24. Dash 24, we would see UNF, that means it's a fine threading, but here we want the coarse threading, so that's 3/8-16. We select that, and it looks like it's the correct size hole. Now here, looking at the drawing, we see that the call out for the depth is through. And that means that we're only going to cut the hole into the next cavity. So basically, it's going to make sure it's threaded all the way into the next pocket and no further. So there's a couple ways to do that. Right now, the preview just shows us this hole going into the center of the pocket. Well, that's not cutting anything beyond the hole, so this would be just fine. But another thing we can do, instead of just arbitrarily selecting blind, we can actually select up to next. And what that's going to do is make sure this cuts all the way into the hole, but no further. So that means if this hole were to change diameter, either smaller or larger, this will change with it and make sure that we have the hole go all the way in. So either one is up to you, but I like using this up to next option for the end condition. Okay, and it is threaded all the way through. Now, the next thing you have to do before you get out of this tool is you have to make sure you select the appropriate options. So you want to select this button here that says cosmetic threads, because in just a few moments, we're going to see how to turn on the cosmetic threads. And instead of having actual physical threads in the hole, it's going to paint a picture of threads in the hole and make it look like it has them there. And this is where a lot of people get tricked thinking that you need to use the thread tool, because if you don't select this option and don't turn on the cosmetic threads, well, then you're not going to see them and you're going to think that you made this feature incorrectly. All right, well, this looks good, so we'll select OK. Right? And right now the cosmetic threads are just this dashed line, so that's showing us that this is the hole that we'll drill, and then this is how big the threads are actually going to cut out into the part. That's 3/8 inch diameter. But we're going to turn on the shaded cosmetic threads in a minute and we'll see the threads in the hole. Let's first, however, put in this hole wizard feature. We're going to do the same thing. Hole wizard, select straight tap, positions. We're going to select that hole. We're going to select that hole. All right, back to type. Now in this case, it's a 5/16-18 UNC. So go back to hole wizard, ANSI inch. This time we're going to select 5/16-18. We're going to do up to next again. Come back. And we can see that here the hole cuts just into this pocket and no further. So up to next, make sure we have cosmetic threads and press OK. All right, great. So now we have all the threaded holes. We'll make sure to hide the hole locations. And the last thing we need to do is just add the fillet at the base of the part. So we'll grab the fillet tool. We're going to select the base edge, and in this case, it is a 0.1875 inch radius. All right, perfect. So that's it for creating the part. And we want to do some double checking. So we'll make sure we didn't miss any features. We have the pocket correct. We already sectioned the part to make sure we had that hole with the conical tip. We've added the threaded features in there. Everything looks good. So the next thing we need to do is make sure we turn on the shaded cosmetic threads. So here's how you do that. Right now, the tapped holes only show this little dashed line representing the cosmetic threads, but we want to see the threads painted in the hole. So after we're finished, what we're going to do is go up here to Options. Under Options, we go to Document Properties. Under Document Properties, we go to Detailing. And under Detailing, we want to select this option that says Shaded Cosmetic Threads. So once we select Shaded Cosmetic Threads and press OK, we can then see that the hole has this little picture painted in it. So what I'm going to do is section the part again. So let's look at the hole carefully. If I zoom in, you can see that it has not cut 3D threads in the hole. It's just put a little picture. But it makes the part look more realistic, representing what this threaded hole is going to look like. So you have to select Shaded Cosmetic Threads and double check that option first before you assume that the Hole Wizard did not work correctly, because the case may be that the Hole Wizard did work correctly, it's just the Shaded Cosmetic Threads have not been enabled. All right, so that's it for building the part. What we're going to do in the next segment is put this part into the drawing environment and learn how to make an engineering drawing from it. All right, before we create the drawing, we need to make sure that we have the correct drawing template. So first, you'll want to go to the Welcome to MAE 52 section on the Canvas page, and down near the bottom, you're going to see the MAE 52 drawing template zip file. So you'll want to download that, and then you're going to want to extract all the files and put this in a location that you can find again. Next, what you're going to want to do is get into SolidWorks, go up here to Options, and under System Options, you'll see File Locations. When you select on File Locations, under Document Templates, you'll select Add, and then you're going to go find the directory that has these new drawing templates in there, and you'll want to add it to the list. So what SolidWorks is going to do is going to look in all of these folders for drawing templates, and it's going to bring them in. So you're not only going to have the default SolidWorks drawing templates, but you'll have this MAE 52 one as well. And you're going to need that for the midterm project. All right, so starting with the part, we'll go to File, Make Drawing from Part. And you can see that now under Templates, I have a new tab called the MAE 52 Drawing Templates, and that's the name of the folder where I put the drawing templates in. So I'm going to select that drawing template and press OK. And now it's going to bring me from the part area into the drawing area. So let's start by dragging in one of the views. And if I didn't have that, I could also select Model View and then select the file and then select one of the front, top, or right views. But since we have this, let's just drag one in. Right now I'm going to drag in the front view because it's going to make the projections. So I'm going to put this in the approximate location, and then because I'm still in the projected view tool, when I drag the mouse to some side of this view, it's going to make a projection. So I'm going to need the right view, I'm going to need the top view, and if I drag it a diagonal, I'll also get the isometric view. Perfect. Now, if you don't select the front view, that's okay. If you select something like the top view, it's not going to give you the correct locations of the projections. That's okay. All you need to do is go back to Projected View, select on one of the views that you've chosen, and then drag your mouse into the correct position. Or you can start at Model View again. But if you select the front view, it's really easy to put all of them in at one time. And now we're just going to arrange these in an approximate location on the drawing sheet. We're going to need to change some options later. All right, so one thing I like to do is go and delete any unnecessary items. So in this isometric view, I'm not going to keep any of the center lines. So I'll just select on the center lines that represent the holes. I'm going to go ahead and delete those. All right, and what I can do is I can select on an individual view and change some properties about it. So if we look at the prompt, we can see that this view is shaded. So what I'm going to do is go back here, and if I select on the view, Then under the view options, I have things I can change, like the scale of the drawing, or I can change the shading. So the one I'm going to use is shaded with edges, and then I'm going to select high quality, and it's going to make this look pretty nice. Right. The next thing I'm going to do is on these views, I'm going to change this to show hidden edges. Now, because these are projections of this one view, the front view, and you can see that this is actually driving the other views also because this allows me to move the views, but simply grabbing on one of these only allows me to move the individual view. That means this one is driving. All right. So because these views are driven by the properties of the parent, then that means if I change the first view that I put in to show hidden edges, then it's going to show hidden edges on all of them. If you didn't want that, for example, you'd need to select an individual view and then deselect use parent style and change it to what you want. Okay, perfect. So now we've shown it in the display states that we like. If, for example, we didn't have the center marks or the center lines that we need, what we can do is we can put those in. So you go up to Annotations, you select Center Mark or Center Line. If we want a center line, for example, you select Center Line, and then you select the two bounding edges that represent where you want the center line to be in the middle of, and it will put that line in. For the center mark, if you select the circle, then it's going to put a center mark in the circle. Now these views already have it, so I'm not going to do it again. Well, this view doesn't have it, so we can go ahead and put that in. So we'll use the center line. I'm going to select this hidden edge, that hidden edge. Now put in the center line for us. Make sure we have them there. That one has it. Great. This one doesn't have it, so we'll put it in the center lines. Okay. And right here. Great. So now we have those annotations in. All right. So now let's go ahead and see how to apply some dimensions on the part. So it's very similar to using the sketch area. What we're going to do is select Smart Dimension, and then we're going to simply grab two items that we want to dimension to each other. So that one's 4 inches, and then we just drag the drawing down. Now, there's a couple ways we can show the drawing. So of course you can put the dimension on one side of the dimension extension lines. You can also select these small circles or dots on the end of the arrows, and that will show the arrows on a different side of the dimension, these extension lines. So this is all depending on how you want to present the dimensions. So in a drawing, there is a little bit of subjectivity, and you're trying to communicate information and engineering intent. So you do have say in how you think is the best way to communicate this information. And so if you're looking at this and you want to place a dimension in a different position because you think it makes it more clear, or you want to show the dimension in a little bit different style, as long as it follows some basic rules, this is okay. All right, so you can see this process is pretty simple. Now, there are some things to remember. I mentioned there are some basic rules. So for example, you want to try to keep the larger dimensions on the outside, and I'll show you why. So for example, if we wanted to put in the dimension to this hole, we can see that right now it's very clear from these extension lines where this dimension is pointing to. However, if we start putting the large dimensions on the inside of the smaller ones, the extension lines cross the dimension lines, and this starts to be confusing what you're looking at. So for clarity, to make sure that you're providing the best communication, you want to try to keep this in a logical order, and you want to start by putting the largest dimensions to the outside. Now, there are some times where dimensions have to cross. It's inevitable, but you want to try to minimize this if possible. All right, and then we'd maybe dimension, like this. Right, and you can see you can just kind of pile these up. Now, if we wanted to dimension the diameter of a circle, for example, so right now, since I'm dimensioning the location of the circle, I'm selecting an edge and then the edge of the circle, and it's locating the dimension to the center. If I wanted to dimension just the diameter, for example, what I can do is I can select the edge of the circle, and if that's the only item I select, then it's going to give me the dimension as a diameter. Now, if we look at the callout for this particular hole on the drawing, we see that it has some other information. So we see that it's 0.75 inch diameter, and then we have a depth symbol and then it's 3.75. So we can either use the whole callout tool or we can do this manually. And I'm going to show you first how to do it manually, and then we'll see the whole callout tool. So when we put in this dimension, under the dimension properties, down here we see this thing that says dimension text. Now, the information that's already in there is code in SolidWorks so that it knows what to put in there. If you delete this, you're going to lose this dimension. So don't delete this, but you can add before, after, above, or below this dimension information that you want. So for example, to the side of this dimension, we need to put in the depth symbol and then put 3.75. So what I'm going to do is in this dimension text box, to the right side of the information that's already in there, I'm going to go find the depth symbol, which right here SolidWorks has some commonly used symbols that we can insert. If we didn't see the item that we need, we can select this button that says CL+, and it has more symbols. And this shows you all the symbols that are available to you in the drawing tool utility. So if you don't see the tool you need, and maybe some other times we're going to need flag note callouts, some other modifying symbols, then we'll need to use this. But right now, we see the depth symbol, so we're just going to click it here. It's going to add that in, and then we can type 3.75. And then you can see right here that the text has shown up. Now to make this look a little bit more clear, we're going to potentially add a space, and then we'll add the appropriate amount of decimal places. And now we can see the drawing callout looks how it does on the drawing that we used to build the part. Great. All right, so now let's see using the whole callout tool to create that exact same feature. So up here under the annotations, we see the whole callout tool. And when we select something like this hole, we can see that it's found information about the location of this, and it is recognized that this hole is a counterbore hole. So you can see that it's put the smaller hole through, and then it's called out the counterbore symbol, the diameter of the counterbore, and the depth. The only thing we need to do is go add that there's 4 instances of this, and then we might want to say that this small hole is through all. So right here, we're going to select the box, and we'll type in all, and you want to make sure you use all capital letters. And then ahead of this dimension, we're going to say 4x, and then we'll put in a space. So that is saying 4 times the small hole at this diameter through all, and then the counterbore at this larger diameter to a depth of 0.1. And we just point this to the edge of the large circle. And you'll find yourself doing that quite a bit. So not with a whole callout, but smart dimension, we want to dimension the fillets, for example. You wouldn't put 0.75 on each one of these fillets. What we're going to do is select one of these fillets. It already says radius 0.75, and we'll want to add in front of that 4x to signify that that same dimension carries over 4 times. All right, now let's go ahead and put in a section view. Of course, we can't dimension to hidden lines, so we need the section view to show the depth of this pocket. So go into the drawing, and you'll want to decide which view that you need to section to show the information. So in this one, we need to section this top view to show the pocket. And if you look how this is aligned, it's aligned basically to the edge of the counterbore. So while the important part is to make sure this pocket is clear, we don't want any other features that are only showing partially cut, because it's a little bit distracting. So we're going to be careful to align this cutting line so that it doesn't cut through any other information that we don't need. We really want to highlight the depth of this pocket. So what we're going to do is go into the drawing, go to the View Layout tab, and we see Section View. Now under Section View, we can select half section or full section, and then there's some different cutting lines. So we have vertical, horizontal, auxiliary, and then we can have an aligned cutting line where we can cut through multiple features at once. In this case, we just want the vertical line. So we select the vertical line, and then we go drag over the view that we want to cut. And so we can see the vertical line showing up, and we have the option to snap. Basically, we're putting in a little bit of a sketch, but the most important thing is, again, to just make sure that we cut through the pocket entirely, and we don't cut anything else that we don't need. So I'm just going to align it approximately right here. And then what I'm going to do is press OK. And depending on which side I bring my mouse on, it's going to put in the view. And then if I want to show a different direction to cut, I can say flip direction, and it's going to be looking at a different side of the part. But of course, this is the direction that we want. Now, if you put in multiple sections, you might have a different section letter than what you want. So if you want to change that, all you do is go into the section view, and we can change this from D to A, for example. And then you can also modify the font. So if you don't like the way the font has showed up, instead of using document font, you can select your own font. And here we could select, for example, 12 point, and then it shows up more clearly. Now, because we have shown the solid lines of this pocket where they were normally hidden lines, we can now dimension to it. 2 inches. So in any one of these drawings, if you wanted to add a dimension or a note, for example, a note, you can select the note item, and then the note snaps very similar to a dimension, but it shows up with an arrow. So it allows you to snap to edges, to points if you wanted to more clearly highlight a feature. In the case of this drawing, we don't need to add any notes because these callouts can be performed with the whole callout tool. But if you had a more complex note, for example, a special surface finish, or you wanted to draw attention to a certain feature in a certain process to create that feature, you might want to add a note. So let's see the whole callout tool one more time. Do the whole callout tool, and we can select these threaded holes. We select those, you can see that it gives us something very close. We only need to modify the depth. So in the case of the depth, on the drawing, it's through. So instead of the depth hole, what we're going to want to do, go all the way to the end, and we will replace the SolidWorks code with the word through. We'll do the same thing for the threaded part. Through. Perfect. So you can see it's quite easy to modify the dimensions and add them. The thing you're going to have to be careful about is to make sure that it's clear and that you have all the dimensions. What I recommend doing is printing out this prompt, and when you created your drawing, go through each one of the dimensions and put a little check mark if you have it to make sure that you haven't missed any. Another way to think about it is you could try to envision rebuilding this part and go through each one of these dimensions. And if you don't have enough dimensions to add a feature, it's likely you've forgotten that dimension on your drawing. So in terms of clarity, like I said, there's a lot of subjectivity in how you create the drawing, but you want to be careful. Like I said, you don't want things to cross too many lines. You don't want to have dimensions on the inside of parts. And so for that reason, you're going to have to be a little bit creative in how you stack some of these up, specifically in the area with this pocket. So there's a lot of information here, and sometimes it can be a little unclear what exactly the dimension is showing. So you can deal with this how you want. If you feel that this dimension is better on this side, just make that judgment call. But the most important thing is having all the dimensions and that they're clearly represented. Okay, so now we want to understand how to modify the back part of the drawing, to put in our name, to put in information and change the date. So when we get to the drawing, we can see that this information is locked. We're not able to actually change anything back here. And SolidWorks does this on purpose. That's because while you're editing one of these views, you don't want to accidentally modify this information, because sometimes this information can be really critical. So what you do is you find a clear space on the drawing, you right-click, and you say Edit Sheet Format. When you edit sheet format, the layer of the drawing that has the views and the dimensions disappears, and then you're accessing the back layer. So SolidWorks puts this on 2 different layers to make sure that you know exactly what you're editing and you don't accidentally edit something that you don't want to on the drawing. Now that we're in the back side of the drawing, what we can do is we can simply double click on these notes to change them. For example, revision, instead of P, maybe we want to say NC for no change. This is the initial release of the drawing. Perhaps we want to change the date. So for example, I could say 04/26/20. If you want to put in an imaginary ECO number, so this is an engineering change request to initialize the generation of this part in drawing, you can change that. The most important thing you need to add is your name, your student ID, and the name of the part. Now, looking at the drawing, you'll see that there are quite a few details. So one thing I see, there's a scale here. Now, if you look at your template And unfortunately, the template that you're given is missing the scale. So here's how you add the scale back in. The scale is automatically linked to the drawing sheet because you can change the drawing scale globally, not just for each one of these views, but for all of them at one time. So if you want the scale to automatically represent what the drawing sheet scale is, then you're going to have to add a note and link it. And here's how you do that. You select note, and then you select in the approximate location of the scale. And then instead of typing in the scale, you can go over here to link to property in the note properties. And when you select that, under the current document, you want to find the property name, and the one we want is the SolidWorks sheet scale. When you select that, it's going to put in the sheet scale, and you see that it's blue. That means it's automatically linked. Now we can drag it around. So if we change the global sheet scale, this will change with it. Now some of these other properties can be linked if you want, so you can change the part name to match your SolidWorks file name. But the most important thing is that this says midterm project, and then it says something like bracket mount. But again, you just need to make sure you include your student name, your student ID, and make the date appropriate. Now, if you're making a real drawing sheet, these dimensions, these default tolerances are really important. So what this tells you is that if you've forgotten a tolerance, which we haven't talked about up to this point, but if you're using this method for anything that you're creating a real part, you'll have to have some tolerance on that because you can't build things to the exact dimension. There's going to be some latitude in the machining tolerance, how well you've marked it out, how well you've done the process. So tolerances are applied to each one of the dimensions. Now, if a dimension doesn't have a specific tolerance on there, the sheet tolerance tells you what to assign to it. So this says that if you keep 3 decimal places, for example, the tolerance is automatically plus or minus 0.005. If you keep 1 decimal place, the tolerance is automatically 0.015. If the dimension is in a fractional format, then you keep 1/32 of an inch. So you may or may not want to change this, maybe not for this project, but in a real context to, again, communicate your engineering intent clearly. You can also add any other notes back here. If you need to add a general notes section, which in another assignment we'll see, you would add it on this back side. And then when you're finished modifying all of these notes, you right-click and say Edit Text. Oops, right-click and say Edit Sheet. And then that brings you up to the upper layer of the drawing. And then you can modify these again without fear of changing the back side. So those are the basics of creating an engineering drawing and adding dimensions, notes, and modifying the sheet text. Before we conclude, I want to show you just a couple other things. So one thing is you might want to change the scale for all of the views. Rather than clicking on a single view and changing the scale for that view individually, which you can if you wanted to make one view a smaller or larger scale. If you wanted to change it globally for the sheet, what you do is you go over here. It looks like the feature tree, but it's really for drawings. You right-click on Sheet, Properties, and then you can change this sheet scale here. Here you can also change the drawing template if you didn't have the right drawing template to start with, or if you had a different one that you wanted to change to. If you want to change to a different size sheet, you can. You can also change the datum labels, so the next sequential section view or detail view will have the appropriate label. If you have more than one sheet, which if you're creating a drawing package, you may have more than one sheet, you can also change the name of the sheet here. Another thing, if you look at the views, you can see that my tangent edges are shown a little bit different. So I have them shown, it's called tangent edge with font. So how I've done that is if you select a view and right-click on it, you can say tangent edge, and then show tangent edges visible, show with font, or remove. So here's what it looks like visible. So it just makes them as hard edges. If you make them invisible, removed, you can see that the part looks like this. I like the tangent edges with font because it shows a light ghosting of the line, so it still, for your eyes, can detect what the features are, but it's not overwhelming by having such a thick line. So if you're wondering how to change your drawing view to make the tangent edge look like that, you just right-click again on any view, and then you decide how you want to show the tangent edges. All right, So again, just like with all the tools, it requires a little bit of experimenting, some learning and exploring the options inside the tool, but hopefully this project will be not too bad. And again, just make sure you go through, check mark that you have all of the drawings and that you could recreate the part from the drawing that you've created. Make sure that you've changed all the appropriate information, and we'll look forward to seeing you next time. Thanks again for watching, and take care.